Welcome all for today's Database Management System 1 online session number 29 of second semester BCA affiliated to Kuvempu University. Dear students, the today's topic of discussion is the set differences and the rename operation which are coming from your relational algebra. So before moving on to today's session and find what's interesting in today's relational algebra there, so let us have a small recap of our previous class there. I think you all remember in our previous session we were discussing about one of the important operation of our relational algebra, that was our union operation. And I think you are very clear about our union operation there. We have discussed what this union operation is, how it's going to be represented, and what is the condition or what is the attribute compatibility we should have to perform our union operation, and with an example we have understood how to use an union operation. So dear students, the learning objective of today's session is to understand the concept, another concept of your relational algebra. To be specific, in today's session we'll be learning two important relational algebraic operations. One is your set difference operation and another one is we'll discuss about your rename operation. So the session outcomes is the student will be able to understand the concept of relational algebra. Specifically, in this session, we are going to cover about your set difference and your rename operation there. So now let us start with the first one, that is your set difference operation there. See, the name itself is telling here we are going to perform the difference operation, and it is being performed on one or more different set of sets there. So now let us understand what is this set difference operation and how it is been going to be implemented in your relational algebra thing there. See, for representing a set difference operation, you will be using a minus symbol, and it is separated by two different sets there. For example, if you consider R and S as two relations or two table, or I can tell two different sets there, then you can represent a set difference operation by using what? R minus S. You can see in the slide there I have written R minus S. See, it represents, when you are writing R minus S, that means that you are specifying about a relational algebraic operation called as your set difference there. See, when someone is going to work with your R minus S there, what it is going to do or what it is going to return there, that's important there. See, R minus S, it returns a relation instance containing all the tuples that occurs in your R relation but not in your S relation, and this is very important there. See, what I am telling here is you have two relation R and another relation as S there. Assume that you have few tuples in both of the relation there. R minus S is going to return you only those tuples which are present in your R relation and they are not present in your S relation. So this is what actually the R minus S is going to do in our relational operations there. So now you should keep in mind that this R as well as this your S relation, both of them should satisfy the union compatibility. So you remember in our previous session we are very clear about what do we mean by union compatibility, isn't it? See, I'll repeat it again for you there. So if you are having two relation R and S, you can tell they are under your union compatibility when the number of attributes in both the R and S are of same. For example, the R relation has two attributes. That means that the S relation should mandatory have only two attributes there. You cannot have less than 2 or you cannot have greater than 2 there. You should have equal. That is, if the number of attributes in both the relation are same, then we call it as union compatible, or we can also tell that the attribute domain should be same. Okay, so if you remember that if you want to perform your set differences, then both your relation R and S should have what? Union compatibility. Okay, so the schema of the result in the schema of the result is the schema of your R. Now let us consider your set difference operation with an example there. Now you can see there you have two set there, isn't it? The first set is called as your S1 and you have your second set which is called as your S2. Can you see here set 1 and your set 2 there? See, the set 1, it has 4 attributes there. You can see here. In the same way, the S2 is having what? 4 attributes there. Now you can tell that these two sets, they satisfy your union compatibility. or the attribute domain is compatible here, because here also you are having 4 attributes, here also you are having what, 4 attribute. Now it is capable of performing your S1 minus S2, that is your set differences among your S1 set and your S2 set there. See, in your S1 as an SID you have 3 values, 22, 31 and 58, followed by its S name, rating and age value. Similarly, in your S2 table or your S2 set there, you are having 4 tuples there, 28 with the SID 28, SID 31, SID 44 and SID what, 58 there. And all the tuples are having this related S name, rating and age value there. Now when you perform S1 minus S2, see what is that S minus S2 is telling that when you perform S1 minus S2, you are going to get a instance of the tuples which are present only in S1 and which are not present in your S2. So when you do this one, you will get an output like this. S1 minus S2 will be only, you will be getting the value that is 22, Dustin 7 and age with 40.0. So this is why you can find out there. See, this S2, that is in the set S1 there, the first tuple is having the SID value as 22 with Dustin 7 and 45. You can find out that in the set S2 you don't have this SID with number 22 there. Therefore, since S2 is present only in S1 and it is absent in your S2, you will put it in your S1 minus S2. That is done. Now, we'll go for your second attribute there, that is 31. See, 31 with the SID 31 is present even with your SID with your second, that is S2 there. Therefore, you cannot include 31 in your S1 minus S2. Understood? In the same way, 58 is also been present in your set S2 there. Therefore, you cannot include it in your S1 minus S2. Therefore, the output will be that you will be having only one instance of your result, that is your 22. I think you have understood. ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ? S1 ಅನ್ನೋ ಒಂದು ಸೆಟ್ ಇದೆ, S2 ಅಂತೇಳಿ ಒಂದು ಸೆಟ್ ಇದೆ, ಅಥವಾ ಟೇಬಲ್ ಅಂತಲೇ ಕರೆಯೋಣ. ಎರಡೂ ಟೇಬಲ್ನ ನೀವು ಸೆಟ್ ಡಿಫ್ರೆನ್ಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ಫಸ್ಟು ಈ ಇಬ್ಬರು ಮಧ್ಯದಲ್ಲಿ ಯೂನಿಯನ್ ಕಂಪ್ಯಾಟಿಬಿಲಿಟಿ ಇದೆಯಲ್ಲ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು. ಯೂನಿಯನ್ ಕಂಪ್ಯಾಟಿಬಿಲಿಟಿ ಏನು ಹೇಳುತ್ತೆ ಅಂದರೆ ನಿಮಗೆ ನಂಬರ್ ಆಫ್ ಆಟ್ರಿಬ್ಯೂಟ್ಸ್ ಇನ್ S1 is 4 and number of attributes in your S2 is also 4. Since both are 4, you can perform what, your set difference operation, because they have union compatibility. ಈಗ S1 ಅಲ್ಲಿ ನಿಮ್ಮ ಹತ್ರ 3 ಟ್ಯೂಪಲ್ಸ್ ಇದೆ, S2 ಅಲ್ಲಿ ನಿಮಗೆ 4 ಇದೆ, ಟೋಟಲ್ 7 ಟ್ಯೂಪಲ್ಸ್ ಸಿಗುತ್ತೆ ನಿಮ್ಮ ಎರಡೂ ಕಡೆಯಿಂದ. S1 ಮೈನಸ್ S2 ಏನು ಹೇಳುತ್ತೆ ಅಂದರೆ S1 ಅಲ್ಲಿರೋ ಆಟ್ರಿಬ್ಯೂಟ್ಸು ಅಥವಾ ಟ್ಯೂಪಲ್ಸು ನಿಮ್ಮ S2 ಅಲ್ಲಿ ಇರಬಾರ್ದು, ಅಂಥದ್ದನ್ನು ಮಾತ್ರ ದಟ್ ವಿಲ್ ಬಿ ಎ ರಿಸಲ್ಟ್ ಆಫ್ S1 ಮೈನಸ್ S2. So from just the observation you can find out that the SID with number 22 is present in S1 and it is not present in S2. Therefore, the output of S1 minus S2 will be 22 with its values as S name as Dustin, rating as 7 and age as 45. So this is how the set difference operation in your relational algebra will work. So I think, dear students, you are very clear now. What is this set difference operation? How it has to be performed? So before performing set different operation, you should first check out with your union compatibility. ಒಂದು ಯೂನಿಯನ್ ಕಂಪ್ಯಾಟಿಬಿಲಿಟಿನ ಹೇಗೆ ಚೆಕ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಾಗಿದೆ.